flat roofs. And as usual, I try to give as many examples as possible. And it will be difficult to make in one whole class, but time is over. So let's see how much we can do. The photo is Seun Sanga a few years ago before the last renovation. And in the background, you can see Umyo forest. So there's something, again, this is a reminder we said yesterday, the exam is next week, Friday, in just 1 week, okay? And only those, especially for those online, the online offline is not an option, okay? You have to everybody has to take the exam. And if you cannot, you need to have a medical reason. And remember, the other 3 sessions will be fully online. So I promised to talk about the exam, and I see you excited. So the midterm exam, somebody's calling the phone. So midterm is 25%, that's the full course, right? So it's not a huge deal, but it's quite, it has some impact in the grades. Final will be the final assignment, right? And you see that the most part are the assignments. The problem is we had only time to do 3, the plans to have 4 assignments. So let's see what we do with the 4th, because the second part will be 4 assignments. We have to do 4, and it's not balanced to have 3 in one part and 4 in the other. But okay, maybe we can have all 7 to account for the 40%. Okay, and attendance is 10%. Actually, in the photo is this classroom. Actually, it's the first theory course. The first class I gave in this university was in this class in 2012. So in principle, I think we have enough seats, so probably can do in this classroom. We will give 5 minutes margin, and the exam is 1 hour, so we have still about 10 minutes margin. Fortunately, on Fridays, there's not class after hours, so if people need a bit more time, we can give a few more minutes, but in general, the hour is more than enough, okay? Differently than online exams, it is okay you will arrive, well, it's not okay, but you can arrive late, okay? So you will meet at any time before the exam ends. But you know, some people came like 5 minutes before the end, they failed. It's impossible to make the exam in 5 minutes. But okay, you will be admitted, whatever. Just try to wake up. So you have to bring your pencil, better than ball pen, and eraser in case you have to correct things, and your ID card. And especially important because we have 55 students. And also I'm more or less familiar with many of you. We have masks, and I'm not used to everybody, so we have to know who is who. So I know many familiar faces, but probably some students I very seldom saw. You can bring a paper dictionary because you will not be allowed to have any kind of electronic device for the exam. It's not very useful, but you can bring it if you feel more comfortable. It is faster you ask me if you don't understand a word. Of course, if you don't understand what is a mullion, then I will not tell you. You can have one sheet A4 with your hand notes on 2 sides. When we did online exams, because everybody is at home, you could use all materials you wanted. But here, if you bring all your notes, your prints, and your books, it'll be a mess. It's not very effective, right? So in order not to stress your memory, you can annotate everything you think is difficult to remember in one sheet. Please, one sheet to your hand notes. No copy and paste of prints, not 2 pages pasted one to another, just one sheet, okay? And one A4 sheet. It should be handwritten. And you have to submit it. It is part of the exam. It is not evaluated, but it will be part of the exam if you do it. Then what is, I don't need to say, but I have to say, right? You cannot talk, copy, cheat, get inspiration, etc. And any kind of electronic device and book prints are also not allowed. And it will be a mix, mostly 30 short questions, mostly multi-choice. We had, well, you all took material, so you will be familiar with it. So it's the same style. And 60% are the questions, 40% is to details. This is why practicing and understanding details is important. Well, this is the rules. I will not read them. It's all common sense. Things which are important, we need to see your face. So I know many people didn't have time to wash the hair and have something. That's okay, but you come to the exam so we can see your face, right? Don't put your hair in the front, so we need to see you are looking at the paper. Yeah, that's kind of silly thing, but in order not to have problems, get ready for that. The memo is important. If you took the material course when it was offline, you already will know. It's important you do the minimum in the memo so you can find things fast. Because if you copy too many things, chances are you're mistaken and then you cannot find them. And whatever your mind is much faster than anything else. If you understand things, you don't need it and you will get to the point very fast. Okay. So we have examples and I got some of the best ones. So this is a typical sheet of a confident student who only needs all those words or formula or numbers that for some reason had to memorize. This is kind of extreme thing, right? So, and this is very common case. This takes so many hours to prepare. So probably this is helping your study because you have to systematize things. But when I look at them, I find many mistakes. And then those students spend more time finding the data than really doing the exam. This is another couple of extreme cases. And then, well, some of them are quite nice. So this could be kind of a small cheating sheet we could provide with the course for your review. The problem is none is good enough. But okay, you have that possibility. This is just to relieve the stress and not think you have to overload everything in your memory. But for most of the questions in the exam and the problems, the details, understanding the logic is more important than having the data. So I have one question for you on the activity sheet, and this is about your possibilities. I will make an online survey in Blackboard, but still I need to know now, and especially for those offline, right? I know everybody here is healthy, and hopefully will be healthy next week. But for those in class, and especially those online, I need to know if you plan to come to the exam offline. Right? If you can, actually, it's not planning. And for those who say, okay, if you say this, no, right? If you cannot do it, just say the reason why not. Activity sheets are there. Okay. So I guess everybody here is yes. So let's wait just a minute for those online. Well, you can always not take the exam, but you're losing 25 points, which is a bit pity. Even if you do very, very badly, yes? Yes. Oh, this is right. So, okay. So this is my problem of not reading. So you're right, it is yes. So, okay, so here everybody will be no. Okay. You know, you have to read things. And I wrote it. But... Okay, let's continue. As I announced, I usually add materials in Blackboard because we cannot see everything here. It is always advisable you have very good books for reference. Books are better than anything else. But if you don't want or cannot, this always helps. So already uploaded reference for the basics of structures and for helping your design and the project, right, drawing. There is one interesting thing. I think there is a full project for a small house. This is example we saw in class. You have the real drawings submitted for the construction permit. So you have a kind of guide. I have more projects of larger buildings, but for some reason the files I have are not very clean. So I'm not sure I can share with you. And then we have also basics for envelope, right? And what we saw already, windows and curtain walls. And especially the chapter of the plazas of curtain walls, you will have the two examples we have in the handout mentioned, including the one we did in class. There were some questions I will share here because I think they were interesting. One was about silicon. And some people asked about the difference between silicon and neoprene and so on. It's a lot of differences. But this is a nice building. Well, it has nice details. This is the Museum of Modern and Contemporary Art in Seoul, next to Gyeongbokgung. And they have a kind of a polycarbonate panels in the facade, which is a possibility. The problem with polycarbonate is that it's flammable. If you have a fire, the whole facade will set afire. But this is low rise, and probably they will have some idea of how to deal with it. Not good idea to use in a high rise. But you see, polycarbonate reacts with the chemicals of the silicon. And this is just 2 years after the building was open. And all the panels are already ruined totally. And then this is all the iPhone 5, so you can get when the photo was done. But you see the silicon you put there. It makes easy to correct errors, but it's not really a good solution, right? Silicon is not thought to be so thick, so wide. And we have nearby, there is the nice Seoul Museum of Education. It's just part of Cheongdok, Tosokwon, Cheongdok Library. And you see that, of course, the door is put with a bunch of silicone around because it's a new door. This is not a nice detail in a building which is supposed to be historical. Not even a nice door, that's another thing. But they're using silicone even to repair the joints between bricks, which is kind of nonsense, I think. Then about the dripping elements, some ask the difference between drip and flashing, right? So drip is just the element which makes the water fall. So it's just whatever prevents the water coming in. Flashing is a sheet of a waterproof material which will cover joints. So we'll make the water run over some joint which is difficult. So a flashing can have a drip, right? But not all drips are flashing. And this is the case. This is an example I used to show in materials. Actually, this is the garden wall of my house in Madrid. So this is just a brick wall. Well, this is the next house, but this is a brick wall with an artificial stone element on the top. So it has a drip, it's the standard. But in the joints, right, the cement at points just blocks that, and then the water runs around. And this photo is taken just 2 years after. Nowadays, like a really, really nice black and white, black and yellow wall, but the plants are covering it. So that small detail makes such a huge change in how things perform. And yes, so since you will have to solve the joints, right? This is something you will have to be very careful and control in the construction site. This is one of the buildings. We saw also materials, also here, not sure. This is a 80 years old building. Those two photos are the same building. And just having that tiny drip makes the brick clean and clear after 80 years. But in this place, they have just a tile, but it is not sloped enough, so the water actually slides on the brick. So you can see the difference. Exactly the same brick, same age, different result. And well, this is here in Seoul. This is old Toshi Hanok. Most of them disappear because they demolish. But this is the end of a roof. right? So when you end the roof, you put the last tile in a way that the water just slides. If you have the wrong tile over there, all the water will destroy the timber below. And this is our school. This is the bridge between the round building and the library. And this is the same, just the water slides, and it's this long time there, so it can just react with pollution. We have plenty here, and then the metal rusts. And I wish they will repair soon, because it doesn't look nice. And this is the structural elements. Just having a small detail would have made the structure to be as clean as it's in the top. So let's go to the lecture, and I will go fast on the introduction because it is the same materials. So I have the link. Sorry, I didn't have time to make a QR code to see last semester materials class lecture on flat roofs. And actually, I checked the YouTube. You enter in the minute 17, so you can see in less than 1 hour all the basics. So we don't need to repeat them. The first 17 minutes was the end of curtain walls, which we don't finish. So you can see different examples of similar things we explained, but the link brings you directly to the flat roof. So I will not explain everything. The photos are here, but I will pass fast over them. So we have the strategies, historical outline, design process, and detailing, especially the three main kinds of roofs, then the checklist and case studies. So all these parts will go very fast, but we will stop a bit more in the design process. So remember, we have the typologies, the possibilities of connection, the layering. That applies both to roof and facades. We have to consider the climate first. This is something we just forget in the design process. We think buildings in the same way in Seoul or in Ho Chi Minh. It's not the case, right? And one thing which is proper of roofs, we have to deal with water much more. So we have to see how we deal with the water collection and the snow when it's snowing. So history, we can say we have, even though flat roofs is iconomodernity, we have had flat roofs through history, right? And almost in every culture. I will stop a little bit here because this is Gaudí, this is already modern, and he used a lot of flat roofs. And they had a technology which is called the Catalan flat terrace or Catalan roof, which is quite interesting. This is the detail. I made a diagram, which is not better actually, but shows 3 points which are quite important. First is that the ventilation is lit, so the air can freely move around, and the roof and the parapet are not touching, right? So that ventilation is very important because any kind of filtration will eventually dry, but also the humidity which goes to the top will be washed away. So you will not have this kind of a condensation we see, which is a problem in roofs. Then that also helps to have this kind of a gap in which the roof can expand and contract freely, because we have a direct sunshine on top of it. So it will expand quite a lot. And you have also the coldest part. So roofs are by far the hottest and the coldest part of the building because it has much more radiation than anywhere in the facade. And it gets the whole exposure to winds, snow, and the cold. See one thing, which is the free movement is achieved by these elements. So this is traditionally made of brick. It's kind of brick made slab. This is like a light brick made kind of a honeycomb. So bricks leave the space. That this is the elevation of those elements. So the air may move between bricks. And on top you have just asphalt sheet, which gives some elasticity, but allows just a few millimeters movement without problem. So it will not make damage in those bricks because when it expands and contracts, those bricks may fall down. So there's 3 points that are incredibly modern. So if you understand them, we have some of the basics of modern roof design with different technologies, but 3 points which actually work very well, and still this system is used. There's an example of a modern detail. This has no any kind of annotation. So I invite you to think at home, as you always do, diligently, and try to get the logic of this detail with what we said before. So we have design with water. Water roofs were very trendy in the 1940s and 50s, but have this problem. Water is organic and it creates an ecosystem. So you have to maintain it. It's like a swimming pool. So, and then if it's a freezing place, you have to take care on it when it freezes. And there's a Pompidou, they have a nice reception system. The roof garden is kind of a great achievement that we'll try to deal with it. And this shows that flat roofs is still a big choice because you have extra space to use. That, so let's say how we plan the roof. And the same we saw with the facade. Now multi-layering is the key word. You can have only one layer roof, but nowadays it's mostly multi-layering, and that will define the detailing we do. They should have some explanation. So mostly we will have the base, which is the structure. We will need some element to make the slopes to let the water run, right? Then, depending on the kind of insulation we have, we need vapor barrier or on insulation. And then we have the waterproofing sheet and some protection. The elements we always need will be the waterproof element and the base, right? Insulation can be inside, so it's not always part of the roof. There are technologies to have roofs without slope. It's not the best, but it can be in some climates, right? And you can have a waterproofing material which can stand the aggression, so it doesn't need protection. But this is basically the elements we have, right? The slope, well, of course, the base, slope, insulation, waterproofing, and protection. To make the choice, we have several typologies, different methods to do it. And we have our knowledge of materials, which you will have to review because now I assume you understand the different kinds of waterproofing and insulation and so on. This is how it is explained in the book. Again, it is great, something I advise you to have a consistent graphic for each of the materials you use. What I see here is that sometimes it's very hard to distinguish in some of them. So you have to be very careful when you look at the book. And then this is a more detailed description of those layers. I will call the attention in the separation layer. Sometimes we stick the waterproof to the base and it's okay. But very often we put an intermediate layer to let the free expansion movement of that sheet to make easier replacement or repair, and also to avoid chemical incompatibilities between materials which happen. Then the ventilation is something you try to do the same as in the vertical envelope. In the horizontal is interesting, as we saw before. And then something important in flat roofs, when it rains or you have a hair, right, like ice coming inside of big rain, the sound goes to the inside. You have been in, especially in all the cheap construction, you can feel the water coming on your head. If it is visible, people walking will make also impact noise. So you have to see how we can deal with this noise. And then the leveling, usually have some range, but you need usually the water to run out. And in our project, planning those levels together with the exit points for the drainage is part of our project. And it's also design decision. Just to help, you have the link to the handout of materials. This is the 2020 handout. I didn't change in 2021, so it's last version. Look at it. So this is kind of reminder, we have like 3 families of materials, and all 3 are used widely. They have advantages and inconveniences, but we don't have time to repeat here. But yes, just to keep you awake and to push your memory, let's see how much you remember from materials. And this is a typical thing which happens in the exam, not this exact question, but maybe in the detail you will have to decide the waterproofing. So we have asphalt sheet for the roof, this bitumen sheet, right, in a roof. And this is just over the insulation. You have 4 choices of insulation: extruded polystyrene, Isopink, which is a brand, but still it's very popular here, sprayed polyurethane foam, or rigid fiberglass panel. Which one would you choose out of those? I'm not speaking of the power of insulation and so on. So we assume they are all high density, so they will support the pressure, the weight. And we'll assume they will need different thicknesses, but we will have the optimal thickness. Did you make a choice, everybody? Did you make the right choice? Okay. Somebody still thinking? So this was an easy question. Anemika? Okay. This is something, this is the mix of not compatible materials is very common mistake. Right. So please think about it, and we will comment with the comments. Interestingly, we have I put this because the heat reflecting aluminum foil is very used because it is very thin, so you avoid these kind of thicknesses. The problem is, as far as I know, it's not totally tested. So we don't have a clear calculation method to use this material. Still experiments go on and forth. The makers say it's fantastic because they use it in the space station, so it works because, but buildings are not spaceships, so the construction is much more rudimentary, yes, and less tested. So for what I know, you need to have it inside a closed, empty air layer to be effective. And it must be clean because it works on reflectancy. If it collects dust, which is what happens in buildings, efficiency diminishes greatly. So very careful with it because I see often used in not the correct way, and it's the same as having nothing. The other thing is the aerogel. It's a great material, can be transparent, used in many ways. We have some examples of the aerogel use. The point is still extremely expensive. It's kind of dream material, and it is sold. It's so hard to manage that it's sold like impregnating a felt textile, and you need so little that it's usually from a 3 to 10 millimeters thick sheets. We use this usually in places where we have not the space to put the 10, 20 centimeters of the material. So with 1 or 2 centimeters of this, you have the same power when you don't have a space for that. Still a good choice if you don't need to use a lot of area. So that's the only stop in materials. See the time, because I didn't put the alarm today. So you have to tell me when you have the time, okay? We have several choices, and that's mostly a problem of design, but also climate and budget. The first decision is where to put the water out. The safest is to throw it away, easiest, but you will have always problems with people down. Very often they happen in front of the door, which is not a good decision because when you plan the roof, you are not thinking on the ground floor. Very careful with that. And often with the wind, you'll have problems in the facade. That's the easiest. The most common is to collect it with some kind of drainage. This is the usual, but then you have to design and decide how many points you put, and you will have a cold element inside. So this is wasting energy, it's noisy, and it takes a space. The same happens with sloped roofs. Then we can use the traditional roof in which we have the insulation, and then we put the waterproofing at the top, and the inverted roof in which we have the insulation on top of the waterproofing. This is what is called inverted or upside down. What is that? Because traditional insulation cannot be wet, are not compatible with water. They get spoiled. But with the polymers and so on, we can have insulation which will allow the water to go between layers and still be insulating, not losing the efficiency. And then, as we saw, we have the ventilation, possibility of ventilation. You can ventilate a lot and have even special space, right? Or you can have what we call the warm deck, which means it has not ventilation at all. And you can combine those systems, right? They are, and this kind of ventilation of layering is also possible in the sloped roofs, right? This kind of the garret for kind of a element which is kind of exterior interior, very much used in rural areas to dry grain. In Spain, to dry Iberico in the mountains, so you put the jamon there. So for drying tobacco and things like that, right? This is quite interesting place to work with. And then, of course, you can have the most simple, most cheap, is not usable place. A bit more complex because you need safety and you need more protection is the usable element. And the top is the green roofing, which you have, and can be usable and not usable, but if you put green, you need at least people to go for maintenance. So green roofs actually have multi-layer. You can even have them sloped. This is Pukansan, one of the booths for the control, but usually is inverted. So we have the insulation and then the waterproofing and then the insulation, right, on top of the waterproofing. So this is one kind of insulation which allows the water to go in between. And importantly is a drainage layer. To make things compact, this is kind of prefabricated. This is the same material we saw for the basement walls. Here is horizontal. So the water slides, is not accumulated and can be drained. So that allows for a minimum amount of sand. So that allows to make very, very thin roofs with plants. But if you have trees, right? You have to think in this layer at least 80 centimeters to 1 meter for small trees. That's a lot of thickness and weight. This is the same example. This is another patent with photos. And this is obviously asphalt or bitumen, right? It has a protection because it may happen that some roots go there, so the stronger it is, the better. And you see how we have a felt between asphalt and polystyrene, which was the question we had before. Because in the question before, we didn't have the felt. And you can find those kind of gardens everywhere. This is a Lotte department in Chongyangli, the station, just after it was done. And we have both the usable roofs and non-usable roofs. We have the 3 examples with Chongyangli and Le Corbusier. So the components, or this is the basic typologies. The one deck with all the elements will have from the top protection, if necessary, the waterproof insulation, right, and the slope formation, and then probably the separation felts if necessary. Cool deck is just the same, but that protection is separated in some way to allow the air circulating. That gives better performance. And then the inverted deck, which is the same layers, but with the insulation on top of the others. This limits the choice of insulation materials, of course. And cool deck, both cool deck and inverted deck. So you can have inverted and cool deck together. That's a possibility. But cool deck is usually the first choice, right? Because it is much easier to maintain. It has more protection to the slab. So you have not direct radiation because this will give shade. And any kind of condensation or filtration will be evaporated. So it's quite advantageous. Inverted has also other advantages, right? So once you put the waterproof, the insulation is very light, so you can put insulation immediately, so it will be immediately protected. And since the waterproof sheet, which is usually a bitumen or a polymer, which is very sensitive to heat and radiation, will be immediately protected. And will have not so brutal changes of temperature and so on. So those roofs will be much more durable. This is the second most durable, this is the less durable. But this is the cheapest, and those two are more expensive. So let's see the detailing. And here I will go a bit slower. This is the detail we see in materials. We'll go fast into it. This is from the book, and this is already in Blackboard, but it will be available after noon today, so you can study this weekend for sure. This is a typical detail of warm deck with the graphics of the Blasius book. And see that with the minimum, because this is really minimum green roof, you have up to 70 centimeters of thickness. That's the height of the desk. So it's really thick. That's including the slab, of course. So you have to add the structure. The book gives you the parts by numbers. When you detail, please mark one by one, so there's no confusion. Okay, then when you work, do whatever you want, but counting layers and watching the numbers is a very good way to have clean and fast drawings, but also a lot of mistakes on the construction. So you see what we have, we need to repeat the base layer, the slope formation, the insulation with vapor barrier. Then as this warm deck, we have the waterproofing just on top of the insulation, the drainage layer for the plants, and the planting, which acts as protection. We could say this is cool deck, but actually this drainage part is not ventilated, so it doesn't account. But of course, the plants and sand give excellent protection against the UV rays, right? Because plants are kind of radiation collectors and cool a little bit. Then you have a difficult point, which is the drainage point. See how the pipe needs to be insulated, because this is exterior, so all the air and the cold will come inside. So this insulation is both for heat and for sound, because water is very noisy coming down. And also you have some gap, because this is a hole in the concrete. So in the concrete you have a hole, you have to put a pipe inside. So you need some kind of gap to be able to build it, and then you will insulate around. This is basic construction problem. So interesting point to take care about. The second is that it's hard to see in the detail, but you will duplicate the layers in the turning points. Weak points usually duplicate the layers, and actually you do in 2 stages, because it's very hard to make all at once. And that goes always about 15 to 30 centimeters over the finished floor, just to give some protection against a splash. Doesn't mean you can have water up to that level, because the water will make pressure. All those roofs assume the water does not accumulate more than a couple of centimeters. Otherwise, it will be just spoiled. And finally, you have a cap, which you see has a tiny dripper. So you make sure the water does not affect this difficult joint over there. One thing we don't see here is that, well, because it is sand, so we don't expect so much expansion, but just in case, usually you put some kind of joint at the end of any solid element we add, in this case, the slope, just in case, right? In a very warm deck without this kind of protection, you will need to really protect it, because the roofs expand. So this is the 3 points you consider. And this is the ugly thing I said, and I promised to redraw, but I did not. This is the same, just in a diagram. When we detail, now we're thinking on the roof, right? So we forget about the structure. Just the opposite we did in our assignment. Now structure is whatever, but we are dealing with the roof, right? So we have those problems of insulation with shade and gap. Many people are confused with this graphic here. This is no more than just one pipe with a small neck. So you can put the following one, right? This is what this thing means, right? So you will need to and you always connect in this way, so the water does not go against the joints. One mistake you see sometimes is doing this in the opposite way. So you will have the pipe and then the connection like this, right? And then you will have probably leaks. So very seldom, but sometimes you see it. In this place, I have been clear. It is good practice to have always, depending on the size of the roof, but 2 centimeters is very easy to achieve. And helps also for the fabrication of this part. The duplication of the sheets, and let me use like a clear red. So usually you make a first layer, right? And then you put a second one, and then you continue over to the end, right? So this kind of overlapping in the difficult parts. So you have double, and you try to soften, right, the bending, because those materials, if you have very tight bending, they may crack, and they may end performing worse. And you have, again, the vertical extension, I said between 15, 20, and 30 centimeters, depends on the codes. And we always consider from the finished part, just like extra, at least 20 centimeters. It will help a lot. This is not a problem. So the other thing which creates problems is the gully. So we have kind of the top is kind of the element which collects the water. And then we'll try to have the waterproof sheet to go. So we made a hole and we put the waterproof sheet on top of it. Since this is a weak point, we try to have previously another layer. So if you make the section, this is the waterproof with the opening. This is the pipe in section, right? But we try to make another layer just to make sure there is not leaks around there. So make a previous preparation as we do in the corner, we do in the border here. Since we have too many layers there, if we don't preview well, it will happen that we will have the water exit with many layers of waterproofing, right? And the water will accumulate around it. So it's something you have also to be very careful on how to preview. Because 90% of problems happen around this point. Because where the water accumulates, here they may happen, but if you're careful with the joints and the contraction, it's okay. But the water slides to this point. So it's where the most water accumulates is this more time. So it's where you have to be more careful. And then well, this is a repetition. So this is the detail I told you to study at home. This is the connection of the drainage point. This is a real project solution, so you can check and identify the elements and see how it works in that project. So let's see more examples. Let's see how much we can see today, because we have 30 minutes. Let's not run. If we cannot see all the details, at least they're in the handout, in the materials online, and you can follow the logic. And always ask if something you do not understand. So this small house in Swiss, this is from the book. And this is totally minimalistic. You have a green roof, but it's like showing nothing outside. No drip, no border. It's like typical minimalistic. And they did. So this is like the minimum you can do. Pity they don't show the drainage. Always show the drainage point, right? And it has some kind of green. So probably you will have the possibility to access to clean from time to time. But many things are omitted here. See, this is a structure, but you see how they put this kind of connection we saw before to have a insulation continuity. But when you don't have a wall, you don't have that possibility. And then you have this kind of added insulation, which you know nowadays is not good enough. For today's standards, you need to insulate almost all. You will need at least 5-6 meters of insulation to have the standard. But then you have insulation, vapor barrier, waterproofing. In this case, it seems like it's 2 layers of waterproofing. They don't show the detail of the border, which is a pity. But what I do is to have waterproof paint in this border, some kind of sealing in the border. So in this case, I will not be very confident about this small border. And if it rains too much, the water just will overflow temporarily. So when you don't have any possibilities, just a waterproof paint. And that's it. But even in this case, you have a quite thick, tall roof. And this is the minimum you can make. So it's a good example of minimalistic with difficult points, right? You have one difficult point and another difficult point in terms of insulation. This is a bit more conventional building, but still interesting. Again, from the book, it's multi-purpose building. And this is interesting because we have a terrace. This is something you can access. Things we see here, you have very heavy cladding fixed by angles to the facade. You have, again, water collection probably in the middle, so we don't know how it goes out. But we have one detail which we need always to take care, which is when you have a handrail, where do we put it? If we put on the top, we have a weak point where the water can just infiltrate. So always when you have to put something getting out, it's better you put it in a protected area. So I think this intelligent solution. It's a bit safer also to work in, but you have a clean drip. And you see in this case, you have drip on both sides, which is quite intelligent. Other thing which is interesting is the continuation of the waterproofing all the way to the top. So you have more safety there. And also on the other side. So you see that always you have this kind of minimum 20 centimeters from the finished floor. Other thing is the flooring, which has no, so it's open joints, so the water filters under the floor. So you have the slabs of the floor, gravel. So you can replace, you can remove them, clean, maintain, and put them again. This is quite simple but efficient way of doing things. Very simple detail. Well, this is not so simple. This is, but again, you have to support very heavy pieces of stone there. But well, interesting 2 points I think is worth mentioning. There's another case a bit more complex in which we have a terrace with garden. So we have to deal with two kinds of roof. And that's quite interesting detail. You have a clearly ventilated facade in some way. They don't show the exit, but surely the air moves around. We don't need to explain this part, right? This is well done. You have the gravel and the floating slabs, as we saw before. And we have the parapet, which divides the part with the slabs, right? The part with plants. And see how they put just a kind of line which allows all the water here to go to the other side. This is a drainage layer. So all the water that filters goes to this layer and then goes out, right? And this is exterior, so they don't need insulation. You see the insulation disappears as soon as you go to the terrace, and then you have a difficult point, but the terrace is totally independent. So all the water which is collected in this terrace moves to this hole and goes around. So it gives some kind of humidity to those plants. And then it will have the gully, but you may have also this kind of exit view, and this is kind of a safety opening. So you may have one filter, and in the case this gets full of water, the water will go to this point. So you have like two exits in this point, which is interesting thing. You will see, okay, this is the connection of the roof on the top. So it we saw before. Let's put it here. So in this case, they put 12 centimeters. Again, depends on the codes. And then that endpoint, which is, let's go back, which is always some place you perforate the waterproofing. That's a difficult point. They don't say how they do it, but the same detail we saw for the vertical exit, you will do in the horizontal pipe, not filling it with silicone. Silicone you will need to repair almost every year. So it's interesting solution to quite difficult detail and works in terms of sustainability. You are using water just to plant the green next terrace. Okay. This is a little building which has balconies. So this is the balcony detail. I find it interesting the way they change the structure. Let's go back. So you see the terrace is very thick. And if you go to the front with that thickness, it's quite ugly. So to make it look nice, they do some kind of device to have just a minimum structural element in the front. So you have this kind of thin terrace. If you have all the layers, this element will be very thick. And obviously the aspect will be totally different. So this is to make things lighter. And they achieve that by really a lot of complications. Again, this is one detail which is hard to use anymore. You keep the insulation, but you have kind of final rotation member. This is order made. You see the drip here. You have the water going to the small eave. And this part on the top is perforated. So any kind of water which is accumulated here goes out. The slabs are loose, so you don't have to worry about the expansion joints. And you have plenty of of insulation and 2 layers of waterproofing. So this is some problem you would have very often. You have this kind of balcony in the border. Thick floors often are usually not nice unless you're doing something very massive and that makes sense. So this is a possible choice. Another thing which is interesting is instead of that drainage point is to have a trench. So in this case, the water with the same detail. So this is a perforated sheet, but instead of being an angle, it's a full box, right? So the water, if there's overflow of water, it will go through the trench. Goes from the facade to go to the trench also, but whatever is filtered goes here and is collected in one line next to the facade. So a continuous trench. Also quite common, a good possibility to simplify things and have more safety. And this will go eventually to a gully point. See, the facade is ventilated and always, they don't show how this happens, but probably they will have some kind of, in general, with normal solutions, you will have the waterproof overlap with this element, which is under, right? In this case, they don't say how they did, but you will not stop the waterproof. Guess what point? This is not a good solution. You have always to overlap and make sure the water will slide over the joints, not under the joints. So we have the base, we have the channel. The waterproof has to go over those, right? One more case. Temporary nursery school. And I think this kind of a timber building, this is quite interesting because it's a ventilated, non-visitable thing, and in timber. So in this is like a minimalistic construction, minimal shelter. So it's all light construction. Surely it is a timber framing system, which has just a finishing plates inside and outside. So that provides a very continuous insulation and also very basic structure to support a base element, which produces timber boards with just the waterproofing and plenty of ventilation. Right? So it works very well. It's very light. But again, this is temporary construction. But it explains very clearly the concept of this kind of cool deck. What I'm not so comfortable with being cool deck is that the waterproof is exposed to the sunshine, so you don't have that benefit of protection. But in terms of the thermal performance and avoiding condensation, it is quite interesting. It is quite large. One thing you have to make when you have ventilated layers, more than 20 millimeters and even smaller, is to have some kind of net. This is a perforated or mesh metal, so birds do not go in. Insects will go whatever. You will have an ecosystem of ants, bees, and so on. So you have to deal with it. But the problem is birds. Birds very often come in those layers, and they often get trapped You have a bird agonizing for weeks on your roof. It's not nice. That happens also in the vertical layers. So that's the point we were commenting before. Other thing which is interesting is the ending point. Even in this horizontal roof, you always duplicate the waterproofing in one point in which you have an angle closing and then a small reinforcement. So you give plenty of overlaps to avoid the water filter in these ending points. One more case. This is like a full glass building. And this is, again, another case of a cool deck, but again, with the waterproofing on the upper floor. So this is the same case as before, but in a formal, more permanent building with concrete structure, or well, steel structure, for what I see. This element for filtering the air is the one we know. Let me go back. Right. See the double layer and the gravel to protect it. So in this case, the advantage of protecting against UV and temperature is not so great. They will need replacement every so often. But see how the ending point, we don't see it very clearly, but probably this is one metal element which goes between layers. There's a small drip, right? So the waterproof will overlap over this steel, and probably you have another under, and you have this difficult point. And then you have a different flashing. This is clearly a metal element which connects to the glass. So any kind of water which may come, it will slide, but will slide through the glass because the choice they have is minimalistic in that sense. You have a clear steel structure. You see this angle. This is clearly trying to make this joint as rigid as possible. And the upper part is just one board. Right? So it's probably, there we have a Novofen board. Okay. This is clearly commercial, right? Some kind of a Swiss product. In your assignments and in professional work, unless everybody knows, as you do with the ISO pink, usually give the commercial name plus the generic. So it's kind of gypsum board with a reinforcement or whatever it is. So we don't need to look for it. And I know you know what you're using. Okay, but in reality, usually we put both things to make sure everybody understands what it is. So we're speaking of the cold deck, just to keep you awake. So I was thinking we were going to end almost here. It's 15 minutes before the end. So it's a good moment to put a small question. We commented the cool deck, and I already said by speaking some of the advantages. So can you remember 3 advantages? Because this is kind of the easy exam questions everybody gets, and then you have them with you. Somebody? So advantages of cool deck, and we already commented those 2 examples we saw are clearly cool deck, but they lost one of the advantages by the way they are designed. But there are 2 more. Well, you can find even more, but actually I think 3 is a nice number. Yeah, there's nobody very good with computers. How can we make this big? I tried everything, but it is small always. I don't know why. It should appear in the bottom and larger. Okay, who got at least 3 advantages? 2 advantages? Well, that's okay. That will be if exam 1 question is average 2 points, you might have like a 0.5 or 0.2. Not bad. Let's continue. One more example. Again, this is a large terrace with another kind of handrails. So it's different case, and also with the French doors to go outside. Again, this annoys me. They don't show the drainage point, which is difficult, but okay, they have the secrets. See, something which is continuously used in those projects is the open joint floor. So the water drains to the floor, never accumulates. You have it perfectly leveled. You have always nice cap on the borders. So there's not an expansion problem. And a nice extension of the waterproof in vertical, right? In this case, the difficulty is the ending point, as usual, with the handrail, and the continuity of the waterproof layer. This is a rendered facade, so that makes it easier to work it. But still, this is one possibility of having continuous solid interior and very continuous insulation outside. So let's take this out, or probably better erase and go back to the lecture. So interesting thing is, again, this, see the small angle to avoid the very acute bending of those elements. This is the most usual. It's usually about 3-5 centimeters. When you buy timber logs, 4 or 5 centimeters is the typical, so just cut and you have this kind of angle. It's very cheap, very effective, and usually they are protected against the humidity and they can last long. Also the duplicated layer, right, going down on this other element on the top. And this inverted, so this is the confusion of the symbology. There, I cannot criticize because they are very good. This is the Swiss standard, but I find easy to confuse those two graphics. This is a drainage layer, right? So the water filters, and then goes under the joints of the waterproofing and whatever exit they have. So the point is then having flashing or metal sheet to make this cap. And this collects the 2 layers of waterproofing. So in this case, you have waterproofing up to the end. And the handrail, which is difficult, but it's fixed somewhere. So the handrail for sure will perforate the waterproof there, and will be always a difficult point to solve and to maintain. The other side is more clear. You see again the corner, the duplication, right, of waterproofing, and then the other elements. And since you have insulation on the back, any problem of expansion contraction is always solved. Green roof, we saw already the detail, and actually Katy Tower was supposed to have a public garden on the top. I never went up, but I wonder if it is really public and open. I didn't try. So this is your Sombe of 2014. That time we had like 5 or 6 assignments before midterm. One of those was a case study of roofs, but it was group work. So this is to do at home. We don't have time to develop it here. So we have the warm deck, cool deck inverted, and then green, which can be any of those. So just think by yourselves on the cost and difficulty, maintenance, insulation. That means heat and sound, right? The safety risk waterproofing and other things you can think in terms of having kind of table of advantages, disadvantages. You may see what is most appropriate in this case. You saw those examples were all from the textbook of the classes. They all elaborate on the same principles, but they make different choices depending on the projects, right? So there's not a perfect solution or the unique. It depends very much on each project. So having this kind of comparison clear will help you also making decisions of design. This is an example of cool deck. This is the same with showing materials. I didn't visit so many more constructions there, but you see, even in painting, you will do the difficult corners first and then give another layer of painting in that area. This is the foil. This is a foil put in a ventilated chamber, so I'm not sure this is so efficient there. And then other problem of the paint, which is the most common solution in Korea, probably is a polyurethane paint. You need to have totally clean base. And tell me how clean we can have a roof in Seoul. It collects dust by the minute, so it's a weak point. Must be also dry, So if it rains, you have to wait to dry totally, or if you have water trapped there. And then it must be, this is before, right? But after, it must be also dry and clean. And people working, so it will just collect dust. If something falls inside or whatever, we have to repaint again. So it is very easy because it's continuous. But the same with the silicone, it depends very much on how good, how skillful is the person applying it. We don't know. By opposition, sheets of polymers of bitumen are fabricated with a small tolerance, so we know exactly where we're putting, but they have many more joints. So this is a very difficult trade-off. This preparation for, so this is quite a wide space, so you have all the systems inside. This is the explanation, this is how this finished. So that thickness allows also for a big gardening space as well. There's an example, this is in Madrid, in which you make the cool deck just by a timber deck, and you may have the swimming pool, which in this case acts as a kind of water roof, right? Very seldom the water will freeze in Madrid. It might, but there are ways to deal with it. So if you maintain it, this excellent element for sound and temperature control. So there's the pool, and always you have some kind of a gap between the deck and the borders. The free expansion is typical. So you have one more example of inverted deck. This is all inverted and green. We don't need to repeat. The point is that we go, in this case with garden and the heavy construction, almost to 1 meter thickness. 1 meter is this. Okay. So when you draw your sections, one typical floor slab maybe 30 centimeters or 15 if you have beams. Then you may have to spend the ceiling whatever you need. But the roof will be thicker than anything else, like in the walls. But I don't think we need to explain many more things. We are already familiar with the cap. We are familiar with this detail, the connection. We know we have 2 separation layers for the sand not going to the filter, and then the water going between the joints and being collected by the lower layer. When you have, well, we'll see, let's see, because we have photos. I don't need to explain later. I don't need to explain now. The cap is metal. It's very simple, but see how in some cases it's not just the 20 centimeters, it's making the waterproof up to the end so you don't have any chance of water going anywhere. It's not always the solution, but this is one of the choices we have. And then almost the same in the other side of the wall. This is a real construction of bitumen layers. Right? In this case, you see they should have gone a bit higher. They were only just 8 centimeters. That's not a good solution. But always we check with 50 millimeters of water for at least 2 days. And then, well, we calculate how much will evaporate depending on the weather. But if the level diminishes more than we expect, we try again until we see where things are happening, right? But you see, this is for the trial. We never expect to have so much water, right? If the water accumulates, this will not work. Making a swimming pool is different than making one roof. This is the same with PVC, with polymer sheet. And you see here, we have a descent, like a 30 centimeters border, right? And with PVC, things are welded. So you have this could be probably a swimming pool. And PVC and some materials are very stable against water and moss and deterioration. So they can be done without slope, like 0% slope. That means that you will have some kind of accumulated water at some time. So you need a very good joints and material which really certified and all the chemical aggression of that. But you avoid a lot of weight with this kind of leveling layer. And also you have a very slow rundown, right? Or very slow evacuation of the water because it has to filter. And this is great, you know, because we study in sustainability, that fast runoff will collect a lot of pollution, heavy metals particles from the atmosphere will go straight to the drain and to our rivers and our sea polluting everything. This slow thing reduces erosion, also reduces the fast discharge to the drainage points, and allows to have a slow filtering of those particles along the way, which is several advantages. And this is the example. So this is like a prefabricated porous concrete, right? Filtering tiles also porous concrete plus insulation altogether. What they do is the insulation has some kind of hole, and you have some tolerance for the water to run, because sometimes the water doesn't run okay. So especially near the gully, you will just give a bit more gap to let the water running out. And actually, you don't need to, you can put it, but you can have it hidden under the tiles. It is inverted deck. Again, it's very fast, very cheap, very safe, but has the trade-off of having to be careful with that water accumulation. This is how it is done in reality. The construction is much dirtier than the drawings. But you see how you have the separation felt always. Mixing two plastics together is not a good idea either. They can react. So you will put some kind of felt. And the water was just goes under the tiles. And we have to go to those difficult points, just filled with gravel. So this is the construction. This was my site architect assistant. This is the construction guy, just checking on those difficult points. And the border is just filled with gravel. This is not a visitable roof. So they usually are not cute, but for this kind of maintenance roof, was quite okay. It's not especially expensive, but it's quite easy to maintain and to use. If we have time, we would see this here. So actually, I don't give any kind of choice. You have the photo, you have the numbers. The graphics are different than in the Blazes book, but you can get the logic by the photo and what you see there. You can find what is what. You don't need to even to choose the materials. So please do also at home if you want. And then checklist. This is also from a basic lecture, so I will not read. I will just comment on a few important things. First is the slope planning. Usually you have to calculate according to the standards and the climate. But a very good approach, roughly, is to make it like a 1 point every 100 square meters. Because it's a 10 by 10 square, very easy to control. It's quite reasonable. Larger than that's a bit bigger. You have a lot of water. And very small will make too many perforations. So, you know, if you make very thick, very large rectangles, you will have a lot of sloping, a lot of weight. If you make too smaller, you will have less slopes with many holes. So the choice between large and small, this is section, right? So you have only one, you have many small ones. You have to trade off between mass weight or many holes in the roof. But well, this is kind of good starting point. At minimum, we put 2 drainage points just for safety. If one is closed, you have the other, but you have to at least 2 choices, right? And then you have always to see how you can get a shaft in the interior. So all those points, the reason they are not in the center asymmetrical, it's probably they are near to one column or some element in which you can connect to some shaft. We try to make as little bendings and strangeways in the water as possible. And of course, this is just for initial planning. Detailed calculation, you need somebody to check for it if you don't do it yourselves. And then this is something clear. So you have to know the basic geometry on how to make sloped plans working together. This has not any logic in geometry. You cannot build it. So you have in floor plan, inverted pyramid will be seen like this, right? So if we make the 3-dimensional drawing, we'll have the points, and this will be like a lines going down a little bit with some height, right? So we'll see those points there, right? If we try to do differently, if the point is there, you will have the same thing. This will be a very steep slope, and those will have smaller slopes, right? So the slope will be different. That's very basic. But when you draw, you have to be clear. So you put the drainage points when you really want, and people knows how to do it. This is what we said. If you're not careful with this kind of a clear path to the water without pumps, the water will collect around. And this is very common. We have always ponds of water around the drainage points. This is quite interesting ad hoc solution for a filter against the drainage points. Remember the expansion joints. This is our science library. And of course, this corner is the problem of what we saw before in facades. This is a weak point, but we'll have always like some cracks around there near the parapet. This expansion of that roofing elements. This is not enough provision of expansion joints, and probably not good joints. So you may have also water filtration deteriorating that area. So expansion joint and that detail is important for the derivative buildings. So this is the project we saw before. You have one element to cover the waterproof on the top, but you see expansion joints. On this plate of sunshine, those expansion joints were every 3-4 meters. So we'll make sure that things will move without problem. And some of the caution points we saw already in the detail, so we'll not need to repeat. And I know you already know by memory because we did many times material, but not bad idea you memorize again for the exam. See how we have a adjustment and expansion areas. And this is a terrible detail. You will have this problem which was before. This area will be weak. I will show at some time. There's not a way to make a gully. You will need like really treat it correctly. And again, silicone is just a cheap construction. It's fast, cheap, and also problems in the near future. So how are we about time? Because we solved the basics, we need, oh, we are over time. You didn't say me. We are 5 minutes over time. This cannot be. Something forbidden. How shall I do? We cannot go back on time. Well, this was exciting, I'm sure. You were so hooked, you didn't feel the time coming on. Isn't it? So we just, well, we saw quite a few examples and we had only 50 slides left. So I just, in the handout, you'll have like 2 examples. This is for an exams. So you can see at home. Those are details you have to find errors. Instead of doing yourself, you find something which is possible to improve, right? And then please make your final question. You can complain of being 5 minutes late, but I asked you to tell me. So please write your last question. Those online, please complete your sheet, especially question 1, and upload before 12.